Hi, I'm Gerardo from AWS.
I'm Muchi from Grab, and this is my architecture.
Today we're going to talk about the architecture of GrabDefence. What can you tell me about this platform?
Yes, GrabDefence is a B2B service built by Grab. At Grab, we used to handle a lot of fraud attacks, and we did a decent job to prevent them. So we believe this kind of service is also needed in the market by others. So we make this a B2B service in the AWS platform, which can be used by others.
Brilliant. Let's dive in. So what can you tell me about the main components of the architecture?
Yes, so let me start from this user device here. So GrabDefence has SDK, which essentially collect a lot of signals from user devices, Wi-Fi, IP address, whether this device has been emulated, spoofed, and then so we can send these events, the collect signals, all the way to AWS managed service for Kafka, and all the way to Neptune here, where we can collect all the information, put this into a graph network database, and do the later processing.
So you're streaming data into Kafka. Why have you chosen Kafka specifically for this?
Yeah, Kafka is an excellent way for us to distribute different kind of signals, and then so which can be later consumed by different consumers, like the service here, where we're going to build a central feature bank, and they need different signals and intelligence from the Kafka to further consume and also build ML model for this.
And how much frequency are we talking about? How frequently are the devices pushing or streaming the data?
Yeah, so it's super high frequency. We are pretty much processing like a couple hundreds events per second and all the way to this service.
Let's talk about Neptune for now. Why did you choose a graph database?
Yeah, Graph database is an excellent database for us to be able to capture a lot of hidden patterns of the fraudster, because it's by nature, it's a graph. So essentially we can capture, say, if these two users, they looks totally independent, irrelevant, but if they share the Wi-Fi, they share the IP address or share something, and we're able to essentially capture this through the AWS Neptune.
Okay, so what sort of queries do you make against Neptune?
Yeah, so for example, I so say, hey, between you and me, are we sharing any devices? Or are we sharing any kind of credit card? All this kind of thing. It's usually super hard through some regular query, but it's super, super easy to be captured on the graph database.
That makes sense. So can you tell me about these other databases? So you've got Redis, DynamoDB, and RDS. What are you using them for?
Yeah, so we have different type of database. It's mostly try to address needs for different data type and later query patterns. For example, DynamoDB is a good way for us to store all the user profiles, and if we need to fetch some attributes of the users, we can use DynamoDB to fetch it quickly. And also RDS, so we have different type of events from the user, and we want to make sure that if we need to join different events for this user, to make sure we can get some kind of comprehensive view for user activities in, say, past X hour or something like this. So we can use RDS to fetch data. And last but not least, Redis, because all the things I mentioned before, they are super complex computations, and we use Redis for the cache purpose, so we can retrieve the data in a super fast way.
Awesome, that makes sense. So how are you exposing all this system to your customers? So how can they ask questions about fraud?
Yeah, so it's pretty much here, right? Our clients is here. So later, say they have a user, they want to do a transaction. How do we do the prediction here? So our clients send events to us, and all the computational service, intelligence prediction service over AWS EKS. And then so the EKS service gonna also try to fetch all the data from all the central feature banks here, along here. And we collect all the signals together along with the rule engine we have to make a comprehensive and non-biased decision for this particular events, and then send the decision back to our customer.
Okay, so how much of this platform is actually multi-tenant versus isolated or dedicated to specific customers?
Yeah, so we spend a lot of effort to make sure so there are no such kind of noisy neighbor issue for our customer. So every customer we onboard, so they essentially have their own dedicated database instance, or DynamoDB here is dedicated table to make sure, hey, everything, so every customer, if they are running super high traffic, the other customer wouldn't be impacted. Along with the EKS here, where it can be easily 10x within minutes if certain clients, they are running certain promotion and they want to 10x their traffic. No other client is going to be impacted.
That makes sense. What sort of scale have you achieved with this architecture?
Yeah, so we are essentially like so at GrabDefence, we're helping we are doing the prediction for millions of users and see like so their day-to-day risk events there, and also like so the daily log like so we are at terabyte level log size.
Every day?
Yes.
That's a lot. So Muchi, thanks a lot for sharing this architecture with us.
Thank you.
And thank you for watching This Is My Architecture. See you next time.